guess we'll go ahead and get started here. I want to give everybody a little time to get settled with the delays today, but welcome. This is remembering how we got here. We're going to be doing some talking about integrating defense in depth into kind of these new school DevOps type cultures that we see growing very rapidly in the marketplace, and the general perception seems to be leaving security in the dust. But we're going to talk about some cultural ways to get kind of the core of what we do as security professionals back into the defense or into the DevOps culture. Cool. So my name is Matt Krieger. I'm the principal security architect for a company called Sports Engine out of Minneapolis, Minnesota. This is Kasim.
Hello, everybody. My name is Kasim Esmail. I'm Director of Network Architecture at Applied Trust, and we're headquartered out of Boulder, Colorado, but we have a local presence here in Salt Lake as well.
Yeah, and so Kasim and I actually worked together when I was at Applied Trust a couple of years ago, and him and I have these long conversations, on a regular basis, just about the differences in what we find ourselves doing now. I work for a very cloud-first company that has really embraced DevOps culture. We ship code 30, 40 times a day. We don't own, a single server that our customers will ever see. Everything we do is in Amazon. Meanwhile, Kasim and I worked on several projects that were, very enterprise, very municipal. We worked in a lot of hospitals together, on big data center projects. And we've kind of seen this divergence over time of we've got old school security professionals that are very ingrained in defense in depth and making sure that we are doing everything that we were taught, in our CISSP classes, and then moving over to companies like Sports Engine where, like I said, we're very, very DevOps oriented. We're very agile. We're putting everything in Amazon. We're like completely dependent on them. And what are the consequences of that? And how do we communicate the need for this type of security that was really built around the idea that you can lock the doors to the data center into, these more agile environments?
Yeah, absolutely. And despite working primarily in the enterprise space, we definitely work with a number of clients that are moving into that either are starting in cloud-first environments or somewhere around this hybrid migration path where they're moving from their current on-premise infrastructure and implementing and incorporating off-premise infrastructure, in some cases making that wholesale migration out to the cloud. And so even though those technology stacks may be somewhat similar and different, those practices across those different environments certainly are diverging. And as we've had these discussions, we keep coming back to there's got to be some set of common themes and actions that we as technical folks and security professionals can start to incorporate into our practices and not have these new workflows like DevOps, kind of leave some of those needs behind.
Yeah, one of the most important things, like we threw at the bottom of the slide there, what we want to talk about today are not going to be, specific technical implementations that everybody can go back and say, hey, we're going to, configure our proxies in this way, and this is how we're going to achieve defense in depth in this environment. But it's really to look at the culture of how security is being ingrained in your organization and think critically about your environment and find ways to get the security practices that we've had in the industry for quite a while into this type of environment.
So as we start to move along, if there are any particular topics that aren't very clear, feel free to raise your hand and we'll certainly clarify at that point. But if you have, we'll have some time hopefully here at the end for questions. So let's go ahead and get started.
Cool.
All right, so as Matt alluded to, we're here to talk about incorporating those security practices into new workflows like DevOps. So really, what are we here to talk about? All these cloud platforms continue to change, and we have so many different abstract concepts and new services and capabilities that are presumably released on a daily, sometimes hourly basis. And that is great for the development world and trying to rapidly deploy products, but that rapid movement can certainly create new challenges to security, which is constantly trying to keep up with those advances. So as those concepts continue to change, what do we have? There is a constant change in the marketplace around how those services are referred to, what do they even mean between different providers and different platforms? And so with all that ambiguity, how do you begin to actually change your information security approach and adapt to those challenges when, depending on your organization, maybe your strategy isn't a security-first strategy. It may be more growth-oriented, it may be partnership or sales-oriented. So how do we get security into that mindset? And ultimately, there's a lot of folks in the room, and we exist at different areas of the service stack. So where in that service stack does your organization focus? We were talking about that traditional enterprise in addition to that move to the cloud. But regardless of what infrastructure you're living on, this whole application development world is changing rapidly. So if you are an app dev first shop, you're probably not investing a whole lot in infrastructure, traditional infrastructure, or possibly even operational security. So where you're existing is going to determine certainly what some of your capabilities are, and okay, cool. Will determine some of your capabilities and ultimately impact your ability to operate continuously. We used to talk about operating continuously in terms of high availability, making sure systems were highly available. And now, with many of our services that the end users are depending on, the expectation is that service is always available. So it's not just highly available, it's constantly available.
So one of the kind of key concepts that I want to touch on is that the entire organization has a basic set of needs, and a lot of times these align a lot more than we would really think. Developers really love to throw around the concept of a minimum viable product. There's some version of this that I can go to a console and I can type in some data and I can get a formatted chunk of data back, and therefore my job building that module is the absolute minimum thing I can do to say that this feature is going to be ready to ship. And then you put some UX on top of that, and you want to make sure the end users can use it, because we're not giving people console access to, and nobody wants to do that. And then sales and product are going to go, what is the minimum lovable product? What is something that we can actually put in the marketplace and have people excited to use? Meanwhile, we're sitting over here in security going, holy crap, don't fuck me over with this minimum crap. So the key to remember is there are common goals throughout the organization, and we're all trying to achieve it in different ways. Because I guarantee you that no one in sales is saying, I want to put something out in the marketplace that's going to leak all of our customer data to a third party and get us in the news, because I'm never going to sell the thing again. The UX people don't want to have to deal with the fact that, hey, we had a breach and now we need to go back and put alerts in and change everybody's passwords and deal with, changing our workflows, in an incident response capacity. And development, those guys, if there's ever a breach, if there's ever vulnerabilities found in the code, those guys are going to have to go back and fix it anyway. So if we just kind of look at this as a common set of goals across the entire organization, it's pretty easy to see where all of these goals align. From a security perspective, there's certain signs of trouble that I've noticed throughout organizations that kind of can show you that you're on a rough path to creating those common goals. If you have some sort of change approval board that only meets on a periodic basis, maybe it's weekly, maybe it's monthly, and your developers are coming to you and saying, hey, we've got this idea, we really want to move forward with it, and you say, okay, get in line, we'll get to you next week, people are going to start leapfrogging your approval board, and you're going to end up with changes that you're going to have to go back and change later in the day, or once it's deployed. Your architecture team needs to be part of your security discussions. So many times I see architecture teams go off in a corner and they say, hey, we've got this great idea, we're going to implement these data models in this way, and then when they bring it to security, security says, we don't want that data to be available, across the board in that manner. So let's back off on that. And then suddenly you end up with more contention where, again, people are going to start end-arounding the process to get the product done so that the customers can buy it and everybody can make money. Policies are something that are a necessary evil in this environment. However, your policy committee should not be something that sits off to the side and says, all right, what's the ideal scenario that is going to keep everything completely buttoned up in the way we want to use it? Because again, if your policies are not attainable, nobody is going to end up following them. There's a couple other, themes on here that I'm not going to go through every single one of them. But one of the key ideas here is to, as a security department and a security organization in general, because maybe you don't even have a security department. Maybe you've got one security guy and a whole bunch of recruits in other departments that are really, kind of backing you up from a security front. But it's important that your security organization is able to operate in more of an interrupt fashion instead of, polling every couple of weeks or month to say, hey, where are we at? What's our current backlog that we need to address at this time?
So when we're talking about defense in depth, what are we really talking about? Well, in that traditional space, we've got three general categories that we typically work with. So physical controls, actually physically preventing somebody from getting to a secure, quote, secure or interesting resource. We have lots of technical controls that exist all at many layers of the OSI stack. And I think kind of the important thing to note here on the last bullet is application data controls. Hello? There we go. All right, sorry. So the thought that you have application data controls seems fairly straightforward when you think about, say, controls like authentication. But as Matt was talking about, those data models themselves, how is the data stored, managed, manipulated, transmitted? That is a control or sets of controls that have to be evaluated uniquely, potentially per application and based on the frameworks that you're using. And then finally, administrative controls. Back to the concept of policies. If all I have is a set of policies that tell me what to turn on, maybe I'm not sure what I should be actively turning off and what the rationale is behind that. I think we've all probably been caught by some sort of a software or a platform upgrade where a feature that you previously had deployed in a well-known state changed in another version, and you had to go back and revisit, some of those foundational requirements and assumptions to make sure that your requirements were actually mapped into that new platform. So, as we step away from that traditional enterprise or physical space, well, what do things look like? Well, in the physical space, we were very concerned about resources. So allocation, provisioning, how we would scale those resources, and certainly space to house those resources. And that commonly was associated with some sort of CapEx in the organization. Having to capitalize those assets, depreciate them, and oftentimes perhaps even finding out that an asset's usable lifetime was not as long as you actually needed from a deployment perspective. So that would tend to throw your CapEx planning into a bit of a tailspin. Conversely, as we start to move into this virtual space, whether this is on-premise virtual or off to a cloud type of a provider, we're now starting to talk more about infrastructure, platforms, software, connectivity, actual services that we're likely subscribing to. And what's really convenient about those is those are a shift to OpEx. So I can be, in theory, much more nimble about purchasing, switching services, because if I can keep that OpEx expenditure roughly flat, nobody's probably questioning my budget very much. But if I am trying to acquire another $500,000 disk array that wasn't on my refresh cycle, it's probably going to be a much heavier lift to try and pull off organizationally. So continuing down that path, as we move from owned infrastructure to infrastructure as a service, we're changing our mindset from being all about the gear. What does it take to build out that gear, pull it off of the loading dock, unbox it, integrate it into the environment, have a life cycle to it, and then ultimately dispose of those assets. Whereas in the infrastructure as a service space, it's all about the trust in the service that you're subscribing to or that you're contracting on. So the thought is hopefully your contracts are nice and tight and address the needs that you're trying to achieve from that service. But all the nuts and bolts of building that environment are not physically running cables and plugging in drives anymore necessarily. It's all about that configuration management and deploying those services in the manner that is needed. From a lifecycle management perspective, you're probably not talking about retiring machines. It's more an iterative cycle of continuing to operate that environment, and instead of treating those virtual machines or those application instances as these special, very unique items that take a lot of care and feeding, you probably have lots of virtual machines, lots of application servers, and you spend your time more hurting them as opposed to care and feeding them. And really, what it boils down to is data management, right? If I ingest data, I'm doing something with it, I'm deriving some value, providing platform service, whatever, and then disposing of that data or doing something else with it. So how I process those bits is a little bit different than just pulling that old drive out and sticking it in a destruction shipper. So let's talk about trust a little bit here. So really, what levels of trust do you have, right? So whether we're in a physical or a virtual environment, you still have multiple implementations of the OSI layer that are taking place. So that's unique code that's running at every one of those layers. Is that code all provided by the same vendor, or is it all even running at the same version level? Are the service delivery teams across those different layers, are they in sync so that you can rapidly deploy and orchestrate across those service layers? And, really, what is having trust in that service organization worth to you? Not to dig in too much on some of the recent cloud outages that probably folks have experienced, but I think that illustrates the point that we place a lot of trust as not only information security professionals, but operational folks in these services that we depend on from a day-to-day basis. So what are we actually going to do to enforce that trust and allow those services to work for us in the way that we need them to? And when it comes down to it, nothing's new here, right? I used to have to trust my data center team to be able to deploy networks, servers, whatever those components were in the manner that I needed for them to work. Well, now somebody is doing that in a cloud environment, and I just need to make sure that I can interface with them and provision things in the manner that I need. So nothing's really new here. What does DevOps really have to do with the intersection between these worlds?
Yeah, so where it really comes down to is DevOps, the DevOps culture that is coming into infrastructure management comes from this kind of shortened feedback loop. As Kasim was saying, it used to be you would order servers, someone would unbox them, you'd have an integration team go put them in your data center, make sure you had all your power and cooling in place, then your server team would come and spin up the blades, your network team would make sure that you had the right drops and everything, and there was a longer period of time to really get all your ducks in a row. And now, when people have ideas and development teams can turn on new services, it's a matter of minutes or hours to turn on an entirely new environment. So we're still left with the same kind of defense in depth needs from your physical, technical, and administrative controls, but there's some changes, kind of at either end of that. Your physical controls are very, very different. If you're running in an Amazon or an Azure or any cloud provider, you no longer have keys to the data center. You no longer have security guards sitting there making sure someone doesn't go in and take the hard drives and walk off with them. If you really want a wall around your data, we're thinking in terms of encryption. So suddenly our technical controls are moving up into our physical controls, and we're starting to kind of double dip on some of our control layers to make sure that we're getting the defense in depth we need. And so, the reason I put encryption there in physical and technical controls is that we want to start looking at ways we're going to be encrypting file systems. And then we're also going to be using application level encryption to take care of some of the most sensitive data that's on those individual drives. And at the end of the day, if we need to toss a drive, we delete the key, that data is useless. And then, at the end of the day, we're going to have our administrative controls that still tell us, all right, this is all the shit you got to turn on, and don't turn any of it off. So moving that forward into, what we're calling defense in DevOps is, as the culture shift continues to move down the line, we're getting further and further away from the idea that there's actually servers behind what we're doing. Who really gives a crap about physical controls anymore? We got people writing code, turning on servers, testing their code, making sure that they can get it, out on the internet and deploy it as quick as possible. So ways that we can manage that is to give people infrastructure as code. We can start to take the infrastructure management portion of it that used to be a very onerous process, involving multiple teams, multiple people, multiple days, and put it into kind of our same software development lifecycle and make it part of product development, so we're including infrastructure and code, in our application and software development lifecycle, so that all of these controls that we've put around the actual products we're making can also control the infrastructure at this point. Our technical controls for everything on the host really remain the same. Again, don't forget that there's servers under there. So we always need, all of our ACLs, all of our firewalls, IDS, IPS, encryption, antivirus, depending on, your environment and everything. But we can also add some additional technical controls on top of that. So where we had technical controls really living at, layers 2 through 7, in our traditional defense in-depth model, we can take a lot of that and turn it into just layer 7 controls. That's where we're adding in things like secure coding libraries, automated testing, all of these things that really live at the top of the OSI model, but give us the defense in depth that we're used to from working our way down through the data center. Your administrative controls with this agility do take on a little bit, more of an important role in your application lifecycle. Whereas you're bringing in multiple teams when turning on a data center environment, your change plans are pretty important in that you've got a lot of people that need to know what to do. The necessity really puts those in place. However, now we've got the ability for developers to go in, turn on a server, put some code out there, run some stuff. We need to make sure that our change plans are templated in a way that really enforce the type of security and checks that we want to see as security professionals. There's always going to be policies involved. Seriously, don't put API keys in source control. This is something that literally we have to tell every single person, when they start secure coding, because it's the easiest place to put these things. However, because of the way that we're moving code around and we're shipping features on a very rapid basis, it's easy for these things to start to get missed if they're hiding in large 5,000-6,000 line pull requests. So with those policies, it's really important to start putting things like peer review on top of those. You can train your entire staff, but if you're ever relying on one person to remember everything that they learned in training at the time that they're creating a change set, they're gonna miss something. So we're gonna start adding behavioral defense in depth on top of all these things. So we have multiple people that were trained maybe at the same time, maybe at different times, but they have different brains in their head. They have different memory for different areas of things. And one thing that somebody might forget, their peer is more likely to catch. And then the final thing is we really need to understand trust boundaries in our environment. So when we build our technical controls, we're looking at ways to manage data flow between trust environments. And I'll just throw together a really quick example here of one of the ways that we've seen these types of things change. Super basic scenario. You've got an application server that needs to make a request to a third-party service that goes out over the internet and therefore ends up traversing an untrusted network. Your firewall rules can be used to create a trusted path through a mixed environment. If you're blacklisting all outbound traffic and making sure that you're whitelisting known good services, which has been widely proven to be the most effective way to catch malicious traffic, then we're going to be saying, okay, we know where this remote service is. We're going to give our servers access to it and create that trusted path. The firewall is your delineation between your trusted and untrusted space. That creates a path of trust. We know our application code is calling a third-party service. We know that it's calling a third-party service that we trust because we put code review in place. Our deploy processes have quality assurance checkups. Maybe we add security checks right into our deploy process. Host-based intrusion detection makes sure that we don't have unknown changes happening to that code base once it's deployed. We know where the trusted service exists because our service provider gave us an IP or a list of IP addresses where their servers live on the internet, and we use DNS servers that we assume are going to return that host name, that IP address. Then, just to make sure none of that gets screwed up, we're going to add a few rules on our firewall to make sure that, okay, we've got these, this list of IP addresses that our application servers are allowed to talk to. Therefore, if we break any portion of that chain, we're going to end up, in a failure state where we're not leaking data, things just aren't working, and that's a better state. Eventually, once the connection is made all the way through, we do a TLS handshake with the remote server. Like I said, keep encryption on everything, and make sure that we have a trusted CA that's that's vouching for that remote device. Now, as we start to see even bigger companies make moves away from the data center environment where we have known IP addresses, and that's a viable thing for them to hand out, parts of this path of trust are going to start to break down. A key example of this would be if anybody here has a PCI environment that works with authorized.net. About a year and a half ago, I see my QSA laughing about this right now. A year and a half ago, they decided that they're going to put their entire environment behind Akamai CDN, which sounds awesome for availability. Akamai is, a trusted provider. However, Akamai has, just a crap load of IP addresses, and they don't maintain that list publicly. So if you went to Akamai's website, they had a frequently asked questions page that said, yeah, you just really need to open up 443 to the entire internet because that's what we use now. And there was actually like a specific point in that FAQ that said, hey, PCI says I have to whitelist outbound hosts. And they said, yeah, but this is a business reason to do it because business. And so suddenly our entire path of trust turns from multiple layers of security and multiple places that we have checks and balances into a place that we don't know where this traffic is going to end up going. We know the host name, but there's plenty of DNS-based attacks, there's plenty of routing-based attacks that could reroute that traffic. Okay, we've got a TLS handshake at the other end. How many times in the last year and a half have we seen keys leaked or certificates issued to untrusted parties, in the name of big companies? These things happen on a fairly regular basis, and if there's really no way to catch it at this point if those certificates are compromised. Conversely, if something happens on our server and our services start calling out to untrusted services, sure, we're allowing outbound access to the entire internet. But, that's because we kind of need to for this one thing. Suddenly, if somebody goes out and buys a $60 GoDaddy certificate and sets up, a service on, and sets up a service that's just there to siphon data, our server is going to trust it because guess what? They got assigned cert from a root CA, and we're calling out to them. Our firewall's allowing it because it's port 443, and Akamai says that we need to do that. So, what does that do to our trusted path? The way that we can address that is start to think about how we're going to pull apart our data and pull apart our request path and build trust at additional places inside the path. So suddenly, let's add a DMZ into our mix. We're going to start pushing all this stuff through a forward proxy and inspect traffic at that point. The only issue with that is now our firewall is a blacklist instead of a whitelist. We're no longer saying, here's a handful of services that you're allowed to go talk to. We're saying, here's some stuff we know is bad. Nobody can go talk to that no matter what, but everything else we're going to allow. Until one of those IPs that we didn't know was bad suddenly turns bad and we're talking to it. So that takes and moves our DMZ into this untrusted zone, which means that anything on our forward proxy could end up in the same compromised position of sending data places we don't know. To protect our application server using the old defense in depth method, let's just null route the internet from our trusted subnets. So no matter what happens, if somebody doesn't configure their proxy properly, their application is going to fail. They're going to go back, figure out what's wrong, go back and fix it. However, at this forward proxy, we need to do something to make sure that we're connecting to the host that we think we are. One thing I should mention there is that in this environment, we don't necessarily want to be decrypting our traffic in the forward proxy because, again, that server is allowed to contact any host on the internet on port 443. So if anything happens there, we have any sort of exploit, that is going to start siphoning information off. So the next way that we can add some more trust into that path is, again, application code. That doesn't change. That's going to be the exact same thing we were talking about before. Knowing where the trusted service exists, we still only know the host name, but suddenly we're not going to care anymore because at that forward proxy, we can intercept TLS connect and use SNI to verify that we're looking for the correct host name itself. So if we're trying to get to authorized.net instead of authorized fake.net, if that ends up getting shut down at the proxy, TLS connection fails, someone's going to go back, look at the code and say, hey, we put a typo in there, we need to correct this. Or if we're adding a new service, let's go get it through the change process to whitelist an additional host name. Because we're only looking at SNI in that DMZ, we're not actually decrypting any of the traffic, and so our barrier still exists all the way through outside of our trusted network. And then we're still relying on the certificate handshake on the remote server. But what we're doing is we're adding a few more checks and balances along the way to make sure that if any one of them break, we're going to have a loss of availability instead of a loss of data. So, and then the other thing I want to add about that is, with those configuration changes, we can really follow a software development lifecycle because proxy configs are represented in text, code is represented in text. We can get developers in there and actually make them cognizant of how data flows out of the network, and they can start to integrate those things into their code pull requests that security wants to see. So, can we agree on a definition of DevOps yet? It seems like we've thrown a lot of things out there. Really, nobody's going to agree on a definition of DevOps, and I feel like anybody working in the DevOps space, if you try to define it, somebody else is going to stand up and tell you you're full of shit. But there's 4 main points that we really want to convey in this talk, and that is empathy, cross-training, visibility, and agility. We want to concentrate on empathizing with our users. They want to be able to get to the data that they're paying for. Our developers want to be able to provide the services that they're supposed to be providing. And we want to just start to unite these different disciplines across the organization through cross-training so that our security teams, which are always incredibly strapped for time, can start to use the horsepower that's available throughout. Can you turn them up?
But as we've been talking through this, one concept that really keeps coming up is that DevOps and that development cycle, when needing to be so very agile, can often breed a lot of leaked data or compromises to that general security process. And what you find is that operational security folks tend to have this mindset that they're playing this role of having to literally clean up what the development group has done. So that they can go ahead and implement the organizational policies or requirements to protect the platform that you're trying to provide. And really where we're trying to get to is this nice nirvana state where both of those teams are actively working together. And defense in depth is not necessarily limited to that infrastructure layer or secure coding practices, but we're, as a team, developers, infrastructure folks, operational security folks, we have an understanding continuum that spans those different understanding areas, and we're equally applying those controls and those policies and those best practices in a coherent manner, as opposed to one team being the quote safety net and having to do a lot of heavy lifting just to ensure that things are the way that you want them to be.
And one thing to add there is that, this is not something where security is just trying to avoid picking up the crap. Development really likes to be able to push their changes out there, see the fruits of their labor, and never wants to hear, hey, we shipped this thing, everybody, that's awesome, new features live, let's go out and grab beers, and then have security go, whoa, guys, hold on. No. Let's sit back and actually draw this back a little bit and rethink how you're doing it.
Or even worse, having to withdraw something.
Exactly.
So, what are security folks scared of, DevOps-wise? Well, first of all, as InfoSec professionals, we're trained really not to trust anybody, right? We are there to question the activities that are taking place and use that justification to ensure that things are the way that we want them to be. Conversely, DevOps really relies on this culture of trust and agility to accelerate that deployment process, and there's an inherent trust in that agility to provide that. So if we don't have a common understanding around what that agility is or what we're trying to achieve with that agility, then we've got a disconnect even on the DevOps side of things. So iterate starts to sound like, well, we didn't really get it right to begin with. Like maybe if we had sat down and thought about it a little bit longer and a little bit harder, we would have had a more complete package or offering to put out. And the reality is that iteration gives you small changes to make those course corrections as opposed to having to hit major forks in the road. Not getting it right sounds like a breach from an information security perspective. It sounds like we didn't think about it before we actually put something out there, which breaches are a lot of work and unfortunately are a reality of today's environment. And when it all comes down to it, I do like beer more than work, right? So what scares me as an information security professional about DevOps is that I'm going to be spending more of my time trying to incorporate those security practices into my environment than doing more pleasant activities.
And so kind of what I alluded to earlier is that, there's a flip side to this also. And this, kind of starts to talk about the empathy portion of DevOps that we mentioned. DevOps folks tend to be really annoyed with security in the same way that security feels like they're cleaning up after DevOps. Again, and it's the exact same point. InfoSec professionals are trained not to trust people. And if you're working in a DevOps first organization and you're on a development or an operations team that is, saying, hey, developers, we really trust you guys to make quality code and we're just going to go ahead and ship it as long as it passes our automated tests. And you put a lot of effort into that culture. To have security come back and say, yeah, but I'm not really sure you guys are doing it right, it just feels kind of shitty. So really being able to ship fast is core to producing good products and having happy development and operations teams. And there seems to be this mindset, out there that if the security folks spend enough time slowing down the process, really overanalyzing everything, they have this idea that they're going to get it absolutely right the first time, and they won't. There's always going to be iteration. There's always going to be, improvements that can be made. And so if the development team sees it as, man, I have to sit here and do a shit ton of work to get ready for security to finally sign off on this thing, only for them to realize, oh, we missed something a week later, and then I'm going to have to go back and redo it anyway. Why don't we just kind of keep the whole process moving and iterate faster on those changes? Because we'll be able to shore up our shop a lot quicker if we can get to that point. And DevOps guys also like beer a lot more than work. It's a pretty common thing. Again, back to the common goals that we have as an organization. As long as we can find those, we can see everybody's working towards the same end. There's this brake pedal analogy that came from a guy I used to work with. He actually still works with him, actually. But security is like brakes on a car. They slow you down so you can make it around the track faster without crashing. It's a great concept. If there is no security, guess what? Somebody's going to go out there, we're going to leak a bunch of data, and then the company's going to go bust because nobody trusts us anymore, and our breach insurance didn't kick in because we weren't, we were being totally negligent, and, well, let's go find something else to do. But there's also a flip side to that. So there's a happy path scenario that this guy's a driving instructor. I'll let him kind of talk to it.
Actually pretty happy when Matt put this all these car analogies together because I could play off them much easier. The thought here with the happy path scenario is that the brakes are there to serve a purpose, right? Slowing down or stopping seems like one of those purposes, but really what we're trying to achieve here is using those brakes as a tool so that you can get around fast, going around a track perhaps, as opposed to just flying off the corner because you were going too quickly. However, how it usually winds up working is like the old high school driving instructor car with a brake pedal in the passenger seat, where as soon as that person starts to feel like you're going a little bit off course, they slam the brakes and stop you and say, we're not going to do that, right? And what we start to find is that, really the best learning happens when you're in an empowered environment as opposed to an environment that is focused on slapping your hand for doing something bad. And really, it's better to allow somebody to learn those controls in a safe manner than to basically put them on a busy highway and say, well, there's the gas pedal, there's the brake pedal, and there's the steering wheel. Go for it. You're trying to go that direction. You'll figure it out, and you should get there relatively safe. Ideally, how it should work is have all these systems in balance, right? My development, my security, so that I can pull these systems together, have them work in tandem, and be able to go nice and quick, and in this case, set a new lap record.
Apparently this just happened last week. He was just telling me this yesterday. I had no idea what it was when I first saw the slide, but somebody broke the record at the Nürburgring, so that's cool.
We were doing slides over beers. So really, the moral of the story here is break use is more than binary, right? Breaks don't necessarily have to be on and off, and neither is a security implementation. It can be analog in terms of applying it differently in different areas, but specifically in the areas that you need to provide the protection that you're trying to seek.
So, again, continuing this conversation through into the DevOps culture is, we've been talking about empathy, a lot in, some of the subtexts of these different areas. As we threw out there, there's a common goal at the end of the day to be able to go home, sit down, drink a beer, and not have to worry about work. And I think everybody has that goal to some extent. Some people do like to go home and work, but at the same time, when you want to turn off, you want to turn off. And all of us have the goal of producing good products, keeping our data safe, and being able to feel accomplished in your job.
And who's actually excited when you're on an on-call rotation when something breaks, right? That pager alert goes off and you get that dread of, oh no. So if we can build those systems and build that trust amongst our teams, then not only we're providing a higher quality product and environment, but hopefully we're minimizing that impact to folks' lives and can be more actionable when issues take place, because we have various checks and balances that we can go back to those known breakpoints, those known circuit breaker type approaches, and be able to systematically analyze a problem and come to a quick resolution.
So we touched on cross-training quite a bit earlier. Really empower the different folks in the organization to back up what security is trying to do. Security should never sit there in the corner and just dictate. It's something that again, you probably don't have time to do that anyway. You have, too many meetings, too many policies to review, too many, incidents to respond to, that kind of thing. Cross-train your organization, get recruits in your development and operations team to really be your boots on the ground and your eyes and ears, because these guys, once they know what to look for and, kind of key concern areas, they will bring more to you than you would think. Automate as much as you can. There's this kind of concept that I've heard from different security professionals that, the coding portion of it, I leave that to the developers. However, if you automate your job, people will use it. Developers love automating things. If you automate security, they will use it. And be visible. Nobody likes to break the build. In a staging environment. So if your security controls and tests are visible to the entire organization, people are going to be more cognizant of what they're doing and their impact on the security posture of the organization as a whole.
So really, as security folks, why should we embrace DevOps? It's trusting, putting that trust in people, and it feels a lot better when you have mutual trust within your teams, as opposed to teams butting heads or these silos of expertise where folks retreat to their technical corners and are unable to have cross-platform or cross-environment conversations, and things turn into shouting matches or arguments. So building that trust amongst that organization just generally feels better, right? It's not nearly as contentious. Devs who trust the security team are more likely to support those security goals. To Matt's point about, it would be great to always have a dedicated security team of folks that are focusing on your needs. But you have to recruit and actively engage other folks outside of that core security team, because the fact of the matter is they have some security responsibilities as well. And if we can do that in a cohesive manner, they're likely going to support those goals, especially if we can tool and automate those needs so that it's not a manual effort every time I need to make a particular change or go through a particular review process. When we're thinking security first, improvements are part of your daily work. somebody is more likely to raise their hand and say, hey, this doesn't quite look right. Maybe we should take a second look at this or review this approach, as opposed to, that's the other team's problem. Let's just kick it over the fence and we'll see if they figure it out or if they have any particular items that they want to address. And really what this all boils down to is reducing that security risk and that surface of your environment and trying to reduce any sort of backlog of trying to secure that environment. Trying to bring those security practices to be more agile and support that agile development, as opposed to just being that hard brake trying to slow down that process. So one thing that we commonly hear of is, well, I've got special requirements, so I need a dedicated environment or I need a different set of services to meet my needs. And really, one of the challenges that we start to run into with duplicating these environments is that, well, now I've got that whole set of software and service stacks in another location that have the same set of policy requirements, same set of protection requirements that I did in my existing environment, but now I have 2 of them, 3 of them, 4 of them, whatever. So how you can adjust to supporting those multiple environments, you can try and scale up your staff, or you can try and scale out your tool sets to help you be more effective. And really, don't let organizational structure be your downfall, right? Ultimately, duplicate costs do catch up in time. I think that move to, that initial move to virtualization shocked a lot of people's data center operations, finding that they had duplicate servers in many cases because they were managed by a different group and a different administrator, and nobody really ever talked to those folks. You start to see this in the cloud environment as well, when all of a sudden you get a very interesting bill and find out that somebody stood up a huge server and let it run for an entire month, and it basically was idle, but you were paying for those resources the entire time. So again, trust your people, align your goals, and when special things come up, work together to identify the best methods for managing them.
Yeah, and so one of the key things that we just want to kind of get out of this is security was never really only about governance. Despite the fact that it was implemented that way in a lot of organizations due to lack of resources, lack of time, or just the way that security really came about in from an incident response first mentality and kind of that visceral reaction to go back and keep that from happening again. People would go, all right, I'm going to sit down, I'm going to come up with a set of rules to make sure that this doesn't happen again. Is really not the way that's going to work going forward. To that effect, you want to make sure you're affecting change in an organization and not implementing failure. I see this a lot when I was consulting, and I've actually found myself going down this path a lot of quite a few times in my current job, and I always try to find a way to bring myself back from that cusp of saying, I'm going to put a policy out there. I'm so frustrated that X is happening, and I'm just going to create a policy that says you can't do this anymore. But the problem is, if you create a policy that breaks the workflow on day one, all you've done is implement failure, and you're not allowing people to actually succeed. So, in any time when you see yourself creating a policy or some new rule to address an issue, sit back and think about what can you do to improve the workflow? Can you create new tool sets to actually help people be more secure in their jobs instead of just telling them that they're failing at being secure?
So let's eat that elephant one bite at a time, right? We talked about not being able to effectively sit down and do a start to finish deployment without potentially running into gotchas. Take them in little bites, right? Use that iterative process to your advantage to check those control points and ensure that you're still on target with where you're trying to go, and celebrate those small successes, right? There will be failures along the way, but the successes feel a lot better, and they certainly feel better than one massive failure because some particular requirement or goal wasn't met.
And remember, your users are very, very useful. If you're there to help them, the best way that you can help, your users, be it end users, developers, operations folks, even, your sales and product folks, make sure that they're there to understand, what your security goals are, and make sure your security goals align with theirs, because then they will help you through the process. Remember, tools are a method to operate. They're not there just to support operations. Like I said earlier, build yourself tool sets, give your users the way, the means that they need to get the job done, and then they will build really cool stuff. Again, this is Kasim's slide with the car stuff. This is basically the same point. I just really like the idea of the monkey trying to create a tool.
And finally, give credit where credit's due. The thought here is that if you're spending your time pulling those tools together and training folks on the core goals and the technology of what you're trying to achieve, as opposed to teaching them the tool, you could, in theory, hand a gorilla a stack of matches and it will figure out how to light the match, as opposed to sitting it in a week-long boot camp and instructing it what the purpose, what a match is, what a match head is, and how you strike. So much of tooling today seems to be very based around that product or the platform that's being deployed. And there was a discussion in the keynote where that change from a Cisco platform to a Palo Alto platform potentially throws the team dynamic into a bit of an uproar because, well, we're not trained on that particular platform. Well, but firewalls, that core technology, take that core knowledge set and apply it to a different platform and use those tools to get you where you need to be.
And I think we're going to kind of wrap up on that note at this point, just because we got a little bit of a late start. Is there any questions? I know we covered a whole lot of ground there, and there's some pretty, soft topics that, can span a bit. And if you don't want to ask here, we'll be around at the conference, all day and tomorrow. So, feel free to stop one of us in the hallway. But is there anything you guys wanted to talk about, in the last minute or two that we got here? Yeah, so one thing that we did in our environment is, our software development lifecycle lives around the GitHub pull request. And we have an open source toolkit called Octopolo that's used to create new branches, create pull requests, and really follow our workflow all the way from the first change in one PR through deployment. We've implemented a change template for our environment so that when our developers create pull requests, there's already, a set of criteria that they need to follow to get that signed off by QA, security, whoever we need, to get that pushed through onto the next phase and deployed out to production. The reason we created those templates is that we also have certain applications that exist, for instance, in our PCI environment. So we just use a different template for that. And then if applications move, we change functionality. Maybe we take something out of our, non-CDE, move it into our CDE. We change the template accordingly. And then the next time a developer goes to work on that, they see a difference and they say, oh, all right, here's some additional checks and balances that I need to follow on this change. And suddenly we've recruited somebody who, was there really just trying to, write some code and implement a new feature. We've recruited them onto the security team to make sure that they're following all the criteria without ever having to hold a training or, take time out of people's day.
In terms of low-hanging fruit, look for those repeatable tasks or those components in your environment that you touch a lot, right? If you're not deploying core switches or firewalls in your environment very regularly, then trying to automate that process probably isn't going to get you as much value as automating an application server spin up and deploy.
Cool. Well, thank you all for your time.